Okay, class, we're about to start part 3 of lesson 6. Now, with part 3 of lesson 6, we're on page 332, and we have factors and multiples. It says when you multiply two numbers to create a product, the numbers you multiply are factors. The pairs of factors that can be multiplied to produce a whole number can be easily listed in a T-chart. What are all the factors of 10? This is example 1. Make a T-chart. You got 1 and 10, 2 and 5, -1, -10, -2, -5. And then as you see, when you multiply them, you get +10. It says count the factors in the T-chart. The number 10 has 8 distinct factors in order from least to greatest. They are -10, -5, -2, -1, 1, 2, 5, and 10. Prime numbers are positive whole numbers with only two possible factors, one in the number itself. Examples of prime numbers are 2, 3, 5, 7, 11, and 13. Note that 1 is not a prime number. For example, 10 is not a prime number because, as just discovered, it has 4 positive factors, 1, 2, 5, and 10. However, the numbers 2 and 5 are prime numbers. The only positive factors of 2 are 1 and 2, and the only positive factors of 5 are 1 and 5. Thus, the prime factorization of 10 is 2 and 5. A number's prime factorization may include more than 2 factors, as in the next example. Okay, now, before we go on to the next example, I want to tell you one other thing about prime numbers. The number 2. The number 2 is the lowest prime number and is also the only even prime number. So 2 is the lowest and also the only even prime number. So if you come across anything you're doing with prime numbers and you end up with an even number that's not 2, then that lets you know that that number is not prime. And then if you think that any number below 2 is a prime number, that is incorrect as well. So we look here at example 2. It says, what is the prime factorization of 12? It says, break 12 into its prime factors. So you could break 12 up to 4 times 3. But as we said earlier, 2 is the only even prime number. So we could break 4 up to 2 and 2. So we could add 2 times 2 times 3. Okay, now, I'll admit, when I do prime factorization, I do what is called prime factorization trees, but I will get to that a little later. Prime factors can be used to find two values that may be useful in simplifying expressions and solving equations. The greatest common factor, GCF, of two integers is the largest number that divides evenly into both integers. To find the greatest common factor, break down both integers into their prime factorizations. Find the prime factors they have in common and multiply those prime factors. This is handy when using the distributive property to rewrite two or more terms as one. It says, what is the greatest common factor of 40 and 140? So basically, you would break these down to their prime factorizations. Like here, we broke 40 down to 4 and 10. Both of these are not prime numbers, but 4 can be broken down to 2 and 2, and 10 can be broken down to 2 and 5. And so we add 2 times 2 times 2 times 5. Now, one other important thing about prime factorization is once you find the prime factors, if you multiply all the prime factors together, it should give you the original number. 2 times 2 is 4, times 2 is 8, times 5 is 40. So it still should give you the original number. Now we break 10 up to 2 and 5 and 14 to 2 and 7. And these are the prime factors as well. It says, see what prime factors the two numbers have in common. Both integers share 2 2s and 1 5. Multiply these common factors. So you'll multiply them, that gives you 20. This is the largest number that divides evenly into both 40 and 140. Note that you can rewrite the expression 40 plus 140 as 20 times 2 times well, 20 times the parenthesis 2 plus 7. Okay, now we go on to the next page. Now we come to what is called the least common multiple. The LCM of two integers is the smallest number that both integers divide into. To find the least common multiple, break down both integers into their prime factorization. Select each prime factor the most times it occurs and multiply all of the prime factors you have selected. What is the least common multiple of 20 and 30? Identify the prime factors of each number. As you see here, we have 2 times 2 times 5 for 20, and 30 we add 2, 3, and 5. Select each factor the most time it occurs. The factor 2 appears twice in 20. So that appears twice. That's more than what it appears in 30. So 2 times 2 would be part of your least common multiple. Now the factor 3 appears once in 30. That's the only time it appears. So we select the 3. And the factor 5 appears once in both 20 and 30. So you only write it once. So the prime factors are 2 2s, 1 3, and 1 5, which would be 60. That'll be the least common multiple. Okay, now, so 60 is the least common multiple. So we'll make our denominator 60, and then we will have to multiply in order to get our numerator, which we would do in upcoming problems. Okay, so now we scroll down here. We have these problems for 6-3. And I don't think they're that bad, but we shall see. Okay, so now we go to number 1. So number 1, they want us to find the prime factorization of the following numbers. So 6. Now remember, I told you I use the prime factorization trees, which I'm going to show you here. So I do 2 lines from here. 6 can be broken up to 2 times 3. Now, once I hit a prime number, I circle it. We know 2 is prime and 3 is prime. So the prime factorization of 6 would just be 2 times 3. That would be your prime factorization. So now we go to the number 2. So it's 21. We'll break 21 up into their prime factors. We can add 3 times 7. Now 3 is a prime number because it only has factors 1 and 3. 7 is a prime number also because it only has factors 1 and 7. So our prime factorization is 3 times 7. Okay, number 3. Number 3 is 36. Now we need to break 36 up. Now we could do this. We could say 6 times 6 is 36. Okay. Now we know 6 and 6 is not prime because, like I told you before, the only even number that's prime is 2. So we could break up 6 to 2 times 3. We know 2 is prime and we know 3 is prime. And we could break this 6 up to 2 times 3. 2 is prime and 3 is prime. So all of these are prime. So we'll do 2 times 2 times 3 times 3. Because typically we try and write them in order from smallest to greatest. Okay, number 4. 54. Now, what I like to do, and this is just a me thing. When I come across even numbers, I usually try and take out the 2 first to get a prime number. So we know 2 times 27. 2 is a prime number. So we got one prime number here. But 27 is not prime. 27 can be broke down to 3 times 9. Now we know 3 is prime, but 9 is not, because 9 can be broken down to 3 times 3. Now if you notice here, all numbers are circled now. So our prime factorization would be 2 times 3 times 3 times 3. That would be number 4. Now number 5, we have the number 70. Now I will break 70 down to 2 times 35. So 2 is prime. 35 can be broken down to 5 times 7. 5 is prime, and 7 also is prime. So the prime factorization of 70 is 2 times 5 times 7. Okay, now that took care of problems 1 through 5. Now we go here to problem 6. It says B. For each pair of numbers below, find the greatest common factor and the least common multiple. So they want us to actually do double duty here. So we're going to break down 6 and 9. This is problem 6. Okay. We're going to break down 6 and 9 to their prime factorization. So 6 will be 2 and 3. 9 will be 3 and 3. Okay, now we look here for the greatest common factor of number 6. The greatest common factor of number 6, the only thing they have in common is 3. So your greatest common factor would just be 3. They have nothing else in common. Now the least common multiple. Now remember, when we do our prime factorization with the least common multiple, we take the most that they have in common. 2 is only in 6, so we'll bring down the 2. We have 1 3 here and 2 3s here, so we'll bring down the 2 3s here. So when we multiply this out, the least common multiple is 18. So this is our answer. Greatest common factor is 3. Least common multiple is 18. All right, so that's number 6. Now number 7, we have 45 and 75. All right. Number 7, we have 45 and 75. So I want to break this down. 45 we could break down to 9 times 5. And 5 is a prime number. We could break the 9 down to 3 times 3. And now this is the prime factorization. 3 times 3 times 5. 75. We could do 5 times, 15? So 5 is a prime number. 15 can be broken down to 3 times 5. And both of those are prime numbers. So now the prime factorization of 75 is 3 times 5 times 5. Now we're going to do the greatest common factor. So the greatest common factor, they have a 3 in common. And then they have 1 5 in common. So their greatest common factor is 15. All right, now we move on to the least common multiple. So what we would do here, we had 2 3s and 1 3 here. So 2 3s will go here. We have 1 5 here and 2 5s here. So then it'd be 2 5s. So now what we would do is multiply this out. And this will give us 225 will be our least common multiple. Now number 8. We have 50 and 125. 50, we could break this down to 2 and 25. 2 is prime. 25 can be broken down to 5 and 5. And those are prime. So we had 2 times 5 times 5. 125, we could break this down to 5 times 25. And then 25 can be broken down to 5 and 5. So it'll be 5 times 5 times 5. Now our greatest common factor would be 2 5s. They both had 2 5s in common, which would be 25. Our least common multiple, there's 1 2, and then we add 3 5s. So this will give us 250. That would be our greatest common factor and our least common multiple. Now number 9, they ask us to solve. We had 30 plus 75, and then they give us this multiple choice here to pick from. So we had 30 plus 75. Okay, now we want to factor out. Now, this is what happens. They're trying to prepare you all for factoring. So they want you to be prepared with the greatest common factor. If you look at 30 and 75, you probably don't know this off the top of your head. So you could go to the side and press 30 and 75 and break them down to their prime factors. So you got 5 and 6, and 6 becomes 2 and 3. Prime factors is 2, 3, and 5. 75, we actually did that up here already. So we know it's 5 and 15, and then 3 and 5. So we know it's 3, 5, and 5. Now, to find out, we want to find the greatest common factor, 30 and 75. So the greatest common factor, we would have, the only thing they have in common is 3 and 5, which is 15. So that means we factor out 15. Now, this is what goes in the parentheses. Now, I'm going to write this out one time to show you all what factoring does for the inside of the parentheses. What you are supposed to do is take both of these terms. The terms are 30 and 75. And divide it by what you have here. So in your mind, this is what goes in the parentheses. Whatever you factor out here is what you divide by these two here. So now, this becomes 30 divided by 15 is 2, plus 75 divided by 15 is, what's that, 5. So our answer here would be 15 times 2 plus 5, which is C. Now remember, this is in your head. Typically, people would just go here, but this is what should be in your head whenever you find that greatest common factor. Now for number 10, we got 11 over 75 minus 2 over 45. So basically what they want us to do, they want us to find the common denominator of 75 and 45. And they want to do it by doing a least common multiple. Now, a lot of you, when you were taught in school, they had something called least common denominator. It was just the least common multiple just at the bottom of the fraction. Now, before we even get into problem 10, problem number 7 has the same denominators, 45 and 75. So as you see here, the least common multiple or the least common denominator would be 225. We already solved that. So if you want to, you could pause the video now and you could write down number 10 and write down these factorizations and put the least common multiple. Matter of fact, I'll write it down so that you all will have this. So for number 10, we got 11 over 75 minus 2 over 45. So we would do the prime factorization trees of 75 and 45. And since we already have this, I could just go right through it, 5 and 15, and then 3 and 5. So we would add 3, 5, and 5. 45, I put 5 times 9. 9 breaks down to 3 and 3. So it'd be 3, 3, and 5. So now we would do our least common multiple, or I'm going to put in parentheses D for denominator. So we would have 2 3s and 2 5s. And that would give us the 225. So our least common multiple or denominator would be 225. So now, to find out what we would multiply by, and I should have actually gave a little bit more space, but you can make your spacing on your paper. So 225, so we noticed 75 had 3, 5, and 5. So we would take out the 3, 5, and 5, and we're only left with 3. So that means that we'll multiply this top and bottom by 3. So 11 times 3 is 33. Now here, our bottom initially start off with 45. We add 3, 3, and 5. We go here to 3, 3, and 5. That means we're left with a 5. So we'll multiply the top and bottom by 5. So 2 times 5 is 10. So 33 minus 10 is 23, and our denominator is 225. So it's 23 over 225, which is A. And that is it for this section for the third lesson in 6. And I will upload this to YouTube, and have a wonderful day.